Yeah, what's up? How you doing, man? You know what I'm saying? It's your boy here. It's your boy here, man. You can call me Hamish or 25 Bacteria. So, you know, we got some questions here. We want to see the techniques that we can use to solve this question, you know what I'm saying? So, let's get started without wasting time, you know what I mean? Let's get to it. Let's get into it. So, some water. Okay, well, so first and foremost, when they give me this question, I don't know like how I'm gonna approach this, you know what I'm saying? So first of all, it looked like integration by parts because I have a function that I have a lot of something. But now what I'm gonna do, I'm gonna let solution. So I'll do like substitution let. Let's say t equal to 1 plus x. It's equal to 1 plus x, you know what I'm saying? And then I'm gonna differentiate these. So okay, so now, no, excuse me, I'm not gonna differentiate. What I'm gonna do, excuse me, because you see I have a ln and I have a 2 letter here. So I don't wanna do like this. So t equal to 1 plus t. So now I'm gonna say, okay, so let me put everything in t here, okay? So now t equal to 1 plus t. So I'll say, okay, so t minus 1 equal to x. You know what I'm saying? So this is gonna be t minus 1 and all this stuff is gonna be t. You know what I mean? But first and foremost, let me differentiate here. So when you differentiate this, is going to be dt. When you differentiate 1, is going to be 0. Equal to when you differentiate the x, is going to be dx. So I want to go ahead and replace everything. So say integral. What is my x? X equal to t minus 1. So t minus 1. And then you have ln 1 plus x. 1 plus x equal to t. Okay, dt equal to dx equal to dt. So why did I do it? My intention was I didn't want to have a lot of expression or a lot of variable in front of ln, so it's like almost the same thing, but I kind of flip it and it's became one variable here, you know what I'm saying? Here's one variable and here's 2 variables, which is going to be easy for me, and then it's going to be easy for me to apply by parts, you know what I'm saying? Variable, so then it's going to be easy for me to do by parts. So I can rewrite these as this, ln of t, the first one, and then t minus 1, the second one, the t. So now, whenever you have a ln of t in whatever function you have, I will encourage you to differentiate ln of t. So now let's do this by parts. So first and foremost, I'm going to write a formula. Integral u dv by parts formula u v du. So next thing, our u, we're going to let u equal to this and dv equal to the rest in this. Okay, so now let our u equal to ln of t. Differentiate this one and our dv equal to t minus 1 dt. This is dv. Okay, so now differentiate this and integrate that one. So when you differentiate u, is going to get du. When you differentiate ln of t, you're going to get 1 over t dt. Now we come, when you integrate this, it's going to give v. Now you can integrate this separate, same as saying integral of t dt minus integral of 1 dt. So when you integrate this, it's going to be 2 t squared over 2 minus t. Okay, so this is going to be t squared over 2 minus t. Okay, so now what we're going to do, take all these, substitute in a by parts formula. Okay, so integral, our u equal to ln of t, dv, our dv equal to t equal to u times v. What is a u? U equal to ln of t times that one. So I can start with u times v. I'll start with v times u. Okay, integral v. What is a v? Our v equal to t squared minus 2 minus t. So I can take t out here. You know what I'm saying? I'll take t out. So it's like t, take t out, t over 2 minus 1. Okay, now times du. What is a du? Du equal to 1 over t dt. Du equal to 1 over t dt. You know what I'm saying? So you see t and 1 t cancel. So now you're going to be left with equal to t squared over t bracket ln of t, and then minus. Now you can separate this. Minus of the first one is going to be integral of t over 2, and then minus a 1 dt. You know what I'm saying? So now you can separate that one and they say this is equal to t squared over 2 and then minus t, both in bracket, ln of t, minus, okay, so a half can go back, because it's have a t over 2, half go back, and they say integral of t dt. Now, negative, negative, plus, because remember there's a bracket here, negative, negative, plus, and they have an integral of 1 dt. Okay, so we can finish up that one. So now let's just make a space here, you know what I'm saying, make a lot of sense. Okay, so now this equal to means when you integrate everything, which is integral of ln of t da 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 da, means integral ln of t bracket t minus 1, okay, dt, we're gonna get t squared da 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 da, so it's gonna be t squared over 2 minus t, okay, ln of t bracket ln of t, and then minus a half t squared over 2. It's going to be a half. So when you integrate this, remember it's power 1. So plus 1 is going to be t squared. And then over the same power here, so over 2. So 2 times 2 equal to 4. So I can just write 4. 2 times 2 equal to 4. 7 is past, so it's going to be equal to 4. Now we go plus. Now when you integrate dt is going to be equal to t. Okay, so since we don't have a limit, so we can say plus constant. But we're not done yet, you know what I'm saying? Because in the equation, they didn't give us t. In the equation, they gave us in terms of x. So we know the value of t. So take the value of t and insert there. So it's going to be, so this, remember, means this is this. When you substitute t, that's how it became this, you know what I'm saying? So if you bring it back, it's going to be x ln of 1 plus x. So integral x, you know what I'm saying? Ln 1 plus x, and then dx. But here we have to substitute various law, you know what I'm saying? So I'll say, okay, bracket. Remember there's a t and t. Let's go slow, okay. T and t, so I can factor out t. Let's put t here out, and then we have a ln of t. So here we're left with 1t minus 1 over 2, and then minus t squared over 4 plus t plus c, you know what I'm saying? And if I want, I can take t out throughout, because there's a t, there's a t, there's a t. So I can take t out common. So I can say t is common, and then a rubber bracket means there's a t here, there's a t here, and there's a t there. You know what I'm saying? Constant, just leave it. So it's going to be t, TDC went out, so we're left with t over 2 bracket minus 1, just ln of t. Okay, minus 1t went out, so we left with 1t, and then that t went out, so plus 1, and then plus constant. So now we know the value of t. What is the value of t? T equal to x plus 1 plus x. So we're going to have to replace t with 1 plus x. So here's going to be 1 plus x. Okay, bracket 1 plus x over 2 minus 1 bracket ln 1 plus x, then minus 1 plus x plus 1 bracket, you know what I'm saying? I mean this bracket here, and then plus constant. So if you integrate all this equation, that's what we're gonna get, you know what I'm saying? So the first question is done, so now we go to question number 2. This one right here. So I'm gonna erase everything and do number question 2. So let's not waste a lot of time. Let's erase that question, do number 2. Question number 1 is done. You know what I'm saying? So if you look at that, then you should be able to understand. Now let's go question number 2. So question number 2 also is easy. So now when the giving, you wanna know like which technique should I use? You know what I'm saying? So now we're gonna have an integral sine ln of x dx. Okay, you know what I'm saying? So if it's me, there's a lot of approach you can do. So I'm gonna have to let. So for now, I don't know, like, can I do by pass or can do so? I'm gonna let. Let's say k equal to ln of x. Okay, ln of x, and then remember this mathematical. When you say ln of x, is the same as say log. Write exactly this x, and your base is gonna be e. Acceptable. So this equal to this. If you want to change ln to log, you say log of exactly the same letter, and then you put under e. So now we're going to do exponential. Exponential, when you push this one here, which is going to be e, and then this one go as a power, and then equal, and then here on the left with x, and log disappear. So also you can do like this, acceptable. Why do that? Because I want to use here. There's something I want to use there. Okay, now also come here. We say k equal to ln of x. Differentiate. When you differentiate k, you're going to give it dk. And when you differentiate ln of x, it's going to give you 1 over x dx. You know what I'm saying? So now dk equal to 1 over x dx. So now if you look careful here, we don't have a 1 over x. You see, there's no 1 over x. So I only have a dx. You know what I'm saying? So I only have what? Dx. So I can replace dx. And then also I can replace ln of x as a k. So everything I want to be k, 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 k. So I'm going to go, okay, so if I want everything to be k, k from this equation, first dx, it has to go. So what is dx? Dx equal to dk times x. So dx equal to dk times x. But what is x? X equal to ek. So I'm going to say ek times dk. Oh, so I want to put everything as a xx. So the value of dx is going to be e power k times dk. This dx. Now ln of x equal to k, and then everything is going to be k now. So I'm going to say integral. Okay, sine. Ln of x. What is the ln of x? Ln of x equal to k here. Now dx. What is the dx? Dx equal to ek dk. You know what I'm saying? So now this is the integration by parts. You know what I'm saying? It's normal integration by parts. So now we can solve this using integration by parts. So first and foremost, let me rearrange. So it's going to be integral ek sine k dk. So now the question is, I always get a lot from a lot of people. I remember one of my friend Kyle. You know what I'm saying? You know, we used to work together and do a lot of questions. Kyle, you know what I'm saying? His name is Kyle, and his brother Matthew, the twin brother. Kyle used to ask me, how do you know which one should I differentiate and which one should I integrate? This is what you have to do, you know what I'm saying? You just have to do a lot of questions. The more questions you do, the more you pick like, oh, whenever I have a exponential and trig, I have to differentiate the exponential. Or whenever I have a ln in something, I have to differentiate ln and then integrate whatever I have. So you used to that, you know what I'm saying? So now, the more questions you do. So for here, I'm going to have to differentiate ek and then integrate sine of k. You know what I'm saying? So now we say this by parts. So apply by part, apply by part, by part. My grade 1 teacher said, don't mix capital letter and small letter, okay? My grade 1 teacher. Okay, so what we're going to do, let's write a formula. Integral u dv equal to uv v du. So we know what is our u. Our u equal to ek. So let u equal to ek. Du equal to ek dk. Now dv, our dv equal to this. So dv equal to sine k dk. So for this one here, we're going to integrate dv, we're going to get v, and then we're going to integrate sine of k is going to give us negative cos k. Negative cos k. So what we're going to do, substitute back in this formula here. So we say integral u. What is our u? Our u u equal to ek dv. What is our dv? Sine k dk. dv equals sine k dk. Equal. Now we go. uv. What is a u? Our u equal to ek. Okay, v, because u and v. v equal to negative cos k. So I'll put a negative outside. Negative front cos k. Minus integral. What is our v? Our v, integral, v. Our v equal to negative cos k. So this negative is going to come behind integral. It's going to make it positive cos k, and there we go, du. What is a du? Our du equal to ek dk. Oh, so it's going to be ek dk. So I'll write ek here and then dk. You know what I'm saying? Oh, so now we have another integral. So let's call this first equation. You know what I'm saying? But we have a problem here because this is another by part. Man, okay, very interesting. So we're gonna have to solve this by parts again. Okay, we're gonna have to solve this by part. We have to treat this by parts, and there we go. Okay, so now take this one here, up here. So we got E. Okay, let's do this. You know what I'm saying? Just separate. We got E integral ek. This one right here, cos of k dk. So we're gonna have to do by parts again. So let u equal to ek and dv equal to cos of k. Okay, differentiate du equal to ek dk, and you have to integrate this. You get v. When you integrate this, it's gonna give you sine of k. Sine of k. So now what we're gonna do is substitute in the integral formula. So it's an integral u. What is a u? U equal to ek times dv. Our dv equal to cos of k. Equal to, now u. What is a u? U equal to ek. Okay, v. What is a v? V equals sine of k. Okay, minus integral v. What is a v? Oh, v equal to sine of k. Okay, now du. What is a du? Du equal to ek dk. Ek dk. You know what I'm saying? So now this one here we know equal to this. So what we're gonna do? Sub this into one. Sub into 1, and then 1 is going to become, okay, what is your 1? Our 1 equal to ek sine of k. Okay, let's do it. So our 1 equal to sine integral ek, I mean this is equation 1, our main equation, ek sine of k dk. Now we go, so negative ek cos of k, and then plus, okay, so now we're going to come and substitute this on here. You know what I'm saying? So plus this, so plus and this plus is going to be the same thing. So let me just save the place, I don't have to write again. So plus, it's like this, plus ek cos of k. So this one we know this is this, so we say, oh, so e over k sine of k. Okay, now plus times the second one, because remember this is this, so it's going to be minus integral sine k ek dk. So now look, so now look, this, it look like that. So what I'm going to take this to the left. It's like if somebody give you y equal to, these are not the same. Let's say m plus d minus y again, because this and this are the same. Look, ek sine k dk, ek sine k dk. I can rewrite that one just in case so you can see. Ek sine k or sine k ek, the same thing. Let me write so you can look alike. Ek sine k. Ek sine k integral ek sine k dk. So you see, these and these are the same. So I can take to the left, you know what I'm saying? I mean, these negatives are going to come in, it's going to become positive. It's like, look, you have a y equal to m plus d equal to y. So these, you come to the left, it's going to be y plus y equal to whatever you have. So this is the same with that one. When it comes, it's going to be plus, which is going to become 2y. So it's going to become 2 integral of ek sine k. Okay, so now this is going to become, when this one comes to the left, it's going to be 2 integral ek sine k dk equal to these and these are the same. You know what I'm saying? I can take one out because ek, so I'll take ek out, and here it's going to be sine of k. I'll start with the positive, and then it's going to become negative cos of k. You know what I'm saying? And then we plus constant. Why? Because you don't have a limit for this question. Wow, so I mean this question is done, but we're looking for, so remember this integral ek sine k, let's come back, integral ek sine k, you know what I'm saying? This, which is this, how did it come from? It comes from that. So excuse me, so this means sine k ek dk. You know what I mean? It was derived from this. So if I write this, it's the same as that one in terms of x. So I'm gonna revise in terms of x. But before we do that, let's get rid of 2. Remove 2 and divide by 2 throughout. So it's like everything here divided by 2. So divide by 2. But before we plus constant first, let's divide by 2. You know what I'm saying? Before divide. So it's like, let me remove this 1, 2. I don't need, because I'm trying to save a space. So it's gonna be I can okay, I can, because divided by 2, so it's gonna be like ek over, so I don't need this one because 2 divided by 2 equal to 1. You know what I'm saying? So I can just say, okay, so this is just a 1. Okay, so now remember, integral of ek sine k, integral of ek sine k, it was derived the way how I replaced before. It was k, it was x. So this is exactly the same as this one, but in terms of k. So now we want to revise in terms of x. Why? Because the question was not given in terms of k. So this is same as that one. So it's okay, so equal to integral x ln of 1 plus x dx equal, so now I don't need k anymore. What the value of k? K equals to ln of x. So this is going to be e ln of x over 2 sine, what is k? Ln of x minus cos, what is k? Ln of x. But we have to plus what? Constant. You know what I'm saying? We're going to have to plus constant. But mathematically, if somebody give you e ln of whatever, let's say ln of y, this equal to y, accepted mathematically. You know what I'm saying? So this equal to x. E ln of x equal to x. So I'm going to replace that one. So I'll say this equal to x over 2. Okay, and that one right here is going to be equal to sine ln of x minus cos ln of x plus constant. Please, one thing here quick, man, do not factorize, say there's a common ln of x. No, this ln of x is like angle. It's like when you say cos of theta, so it's like angle. So you cannot take, if somebody give, let's say sine theta, you cannot say let me take theta out here, I'm gonna left with cos minus sine. No, you can't do that. So that's why here you leave them how it is. So x over 2 sine ln of x minus cos ln of x. So man, that's how you solve the question number 2. We go to question number 3. You know what I'm saying? So that's how you solve. We go to question number 3. Question number 3. Drink your water a little bit. Okay, I think this is more easy. The rays are very easy. Okay, these are actually more of the basic questions. Okay. Okay, so this one, we got integral theta, and they got cos of theta, d theta. So apply integral by party, integral u, dv equal to uv, integral v du. Let u equal to theta, so d theta, du, excuse me, because you differentiate u first, du equal to d theta. Now, this is going to be dv, means this is dv. dv, you know what I'm saying? Like, you get used to them. Like, it's different, so this is going to be dv cos theta d theta. Okay, so now integrate dv, we get v. Integrate cos of theta d theta, you're gonna get sine of theta. You can check an integral table if you understand how this one works. Like when you integrate sine cos, you can check in the integration table. You have a table, you can Google, you can check in your book. Now we're gonna have to substitute back. So integral u, what is it? U equal to theta and then times dv. What is a dv? Dv equal to cos theta. D theta. That is the theta equal to uv. uv means theta sine theta. Okay, now we go v. What is a v? Sine theta. Okay, now du, our du equal to d theta. And these are easy, these are the bottom. So okay, when you integrate sine of theta, get negative cos theta. Okay, so since there's no limit here, means no limit, so you plus constant. So theta sine theta plus cos theta plus c. So it's done, man. That's how you do this equation. It's done. You know what I'm saying? Now we go for the last question. So just erase these because we're done with it. We go to the last question. Make a space quick. You can pause if you want. You know what I'm saying? Just move next. If you want to watch, you can pause. Okay, for the last one, they give us integral start from 0 to 1. So now we have a limit and they have a tcost. Okay, so this is hyperbolic. Hyperbolic is by parts, but it's hyperbolic. You know what I'm saying? So now this is also by parts because you have a function times by a hyperbolic function. When you see cosh, tansh, sinch, cosh, sesh, these hyperbolic functions. You know what I'm saying? But it's not only hyperbolic with it. Certain functions, so that's what we saw was about by parts. So now let's go. We write a formula: integral u dv, uv integral v du. So this equal to t and this equal to that one. Let u equal to t and dv equal to cos t dt. Okay, cool. Now when you differentiate u, you're gonna give it du, and when you differentiate, it's gonna give us dt. Now let's go integrate. When you integrate dv, you're going to get v. And when you integrate cos, you get sinh. Cos and sinh, they don't have like negative, positive, like, you know, sine and cos. No. For hyperbolic, that's for cos and sinh. If you integrate sinh, you get cos. When you, like cos sinh, when you differentiate and integrate the other way around, it doesn't have a negative positive for sinh and cos. So when you integrate cos, you're going to get sinh. Of t. Now what we do, substitute back in the formula. Integral u, what is that? U equal to t. Okay, dv, what is a dv? dv equal to cos t dt, and then equal to, now we go for the next one, so we get uv, what is that? U equal to t times v equal to sinh of t, minus integral v, what is that? V equal to sinh of t. Okay, now times du. What is that du? dt. No, this is finished, man. You know what I'm saying? So this is equal to t sinh of t minus, when you integrate sinh, you get cos. So you integrate sinh, you get cos of t, and then we remember we have a limit. So you know what I'm saying? Since you have a limit, so we're gonna have to substitute the limit 0 to 1. So this time you say, you know, take upper limit minus lower limit. So use that calculate. So what is upper limit? Upper limit equal to 1. So it's going to be 1 sinh of 1. Sinh of 1. You know what I'm saying? And then minus upper limit cos of upper limit equal to 1. Means you substitute, replace this with the upper limit. Then you minus bracket. Now you replace this with the lower limit, which is equal to 0 sinh of 0 minus cos of 0. You know what I'm saying? But 0 times anything is going to be equal to 0. So this is equal to sinh 1 minus cos 1 minus 0 minus plus cos 0. So you can check a calculator and plug this in the calculator, or you can leave it how it is. But a cos of 0 should be, I don't have a calculator with me, but I can, let me see if I got the calculator close to me. If not, please plug in the calculator and then you should get an answer. You know what I'm saying? Okay. I can't see my calculator, but please plug in the calculator and it should be get your final answer. So listen here. Man, I believe you learned from my methodology, you know what I'm saying? You know, try to check a calculator button and see. You learn from how I solve. You learn from mistakes. You know, if they FaceTime a channel, you know, give a credit if you think the credit is due. You know what I'm saying? Share with a lot of people. You know, you have learned from me how I solve this question. And just in case, you know what I'm saying? Some people say, man, you know, you got some music too? We saw you on TV, man. You know, we had your song on the radio station. You know, how do I support your music? You know what I'm saying? Okay, so you can click the link below. You can watch my music. You know what I'm saying? I got some music video too. Support your boy. As you know, man, your boy was homeless for 3 years and a half, man. I'm trying to put things together, man. So, you know what I mean? Support your boy. You know, if you have a $1, $2, 100,000, you know what I'm saying, 1 million, don't be shy, like, man, just put it, man. You can send me to the PayPal. You can go to the Patreon too and support your boy, you know what I'm saying? Cash App. You can do all of that, you know what I'm saying? So you learn from how I solve the equation. You like my music or you're not much into the music, you can share my songs or you can share my video to the people who think who are interested in that, okay? And don't forget to subscribe also to my other channel, to my musical channel. Okay? So I appreciate for your time, man. You know what I'm saying? It's your boy Ian, man. 25 bacteria, like I told you. 25 bacteria, like I told you. I thought I told you. 25 bacteria, man. Jerome Quali, man. You know what I'm saying? So, you know, I still have, look, listen, man. You know, we still got a long way to go. So subscribe, share, click that, you know, like button. And, you know, if you think like I deserve the credit, give a boy credits, man. Give my credits. You know what I'm saying? You know, share with a lot of people, man. If you got question too, please follow me Instagram, Twitter. Just make sure you follow me on Facebook. Go in, hit like button. Follow me Instagram, Twitter, Facebook. Man, if you my #1 fan, like my video, and then you should do that. Go to my Instagram page, hit the like button. You know what I'm saying? Hit the like button, follow me. You're gonna get a lot of some of the stuff I don't post on YouTube. You're gonna go on my Instagram. You know what I'm saying? Thanks a lot for your time, man. Peace and love. Peace and love. We back, yo. Thanks a lot, man, for your time, and thanks for your support. Appreciate it. Thank you.